So you're looking for a pure sine wave portable power station that has the ability to supply up to 500 watts, has other features such as USB type A and C ports, an accessory socket, built-in light, ABS and aluminum construction, as well as a lithium iron phosphate battery. Then you'll definitely want to see this product here put to the test. We'll also be opening it up to take a look at the inside. To get started, let's open up the box. This model is the CN505, and the name of this company is Oukitel. We have this nice package right here holding accessories. We'll take a look at that in a minute. Let's take out this packing here, very nicely packed. And right down here is the unit. Right here you can see the case. Very nice. It's a hard case with a handle on one side. Let's open it up and take a look at the inside. Over here you have your solar panel charging cord. That's the MC4 to the DC jack. And in here, let's take this out. This is your AC cord that goes into the switch mode power supply, which is your AC charger. And that's right over here. This one is rated 19 volts, 4.75 amps. And over here you have the cord for your vehicle for the accessory socket. This will allow you to charge the portable power station from your vehicle. Right here is a closer look at the unit, and you can see it's very nicely designed. It has this spring-loaded handle. These pieces here are polished with a chrome finish. This is all aluminum or aluminium if you're British, and the ends of the unit are ABS plastic. Over here's your power button. You push and hold for a few seconds to power up the unit. Your LCD display. This is where you charge the unit right over here. You can use your vehicle, you can use an AC power adapter, or solar panels. The maximum input is 100 watts for this unit. So depending on which one you use, if you're going to be using a solar panel and it's putting out 100 watts, you got to figure it's going to take around 6 hours to charge this up. And you can see over here, up to 24 volts. Over here is the DC section. To turn it on, very simple, push and hold the button. Once it's powered up, you'll have the ability to use up to 4 amps at 12 volts from this jack and this jack. And the one in the middle, you have an accessory port, just like you'd have in your vehicle, and that's 12 volts, supposed to be regulated. We're going to be checking it out. And the maximum current, 10 amps. Over here, you push and hold this button for AC. Turns on these 2 receptacles if you have a grounded plug. Of course, you'd put it in the bottom one. The ground pin would go right inside here. You're allowed up to 500 watts in total. If you have any USB devices that need to be charged, you simply push this button right here, and then you turn on this section. You'll be able to have USB Type-C. This one here will give you up to 20 volts at 3 amps or 60 watts. Then you have 2 of the USB Type-A ports, 2.4 amps each. We're going to be checking to make sure each one of these can supply up to 2.4 amps. We're going to be checking this one too. And down here you can see it says Type A 3.0, a maximum of 18 watts, 1.5 amps. Now let's take a look at the rest of the unit. And here's a look at the opposite end. Ventilation openings. And over here you have an LED light. Now this light is supposed to be much brighter than the one you'd find on a Jackery and other brands. So we're going to be checking it out. It has a low, medium, and high brightness, as well as SOS. Okay, let's get the testing started. Before I power this up to do the testing, I want to go over just a few more things. The lithium iron phosphate battery inside this unit, according to the manufacturer, after 2,000 cycles, should still have 80% of the capacity remaining. If you look right over here, you can see all the information for the LCD display. The fan on, the 50-60 Hertz cycle, everything right there. Over temp for this unit is 65 C or 149 degrees Fahrenheit. The fan will turn on at 45 C or 113 Fahrenheit. This unit also gives you the ability to switch between 50 and 60 Hertz output. The lithium iron phosphate battery in this unit is a 614 watt-hour. The nominal voltage is 12.8. So let's turn this on, push and hold. And here you can see the display, and it looks just like the EF delta, or resembles it very closely. You have how many hours remaining at the given load. In this case, there's nothing being drawn, it says 0 watts. Over here is the battery state of charge, 96%. You can see right over here, if you're having any problems, there's also a reset button inside this hole that you can press. Turn on this section here. DC, this is all active. USB. And you put this one on for AC. And if you look right over here, you see 60 Hertz. Now if I want to switch it to 50, push these together. 50, 60, 50, 60. All right, so let's turn this back off. First, we're going to turn this on, and let's take a voltage reading of this receptacle. 12.94. So what I'm going to do is, once I do the test for the AC output, I'm going to be putting a load on this for a long time, very high, just under 500, to see how long this will run. Hopefully it runs the full time and doesn't turn off because it is rated 500. When that's all finished and we're drained way down, I'd like to measure the voltage of this receptacle one more time to see if it is a regulated output. These right over here, if I carefully touch there and there, they're all 12.94. Yep, 12.94. Now I'd like to test one of these over here to see if it can handle a 4 amp load. And then I want to put a 10 amp load over here to make sure that's okay. Right here I connected up my electronic load to the DC jack. And you can see it's set for 4 amps. Let me turn it on, and we're going to wait about 15 minutes. And we're going to make sure there's no problem with the power output on this jack. 4 amps, 12.45. You are going to get a little bit of a voltage drop because of the wires I'm using between this unit and here, but that's not going to affect the test. We just want to make sure that the 4 amps can be sustained for at least 15 minutes. Okay guys, 15 minutes has passed. Not a problem at all. It's still holding exactly where it was. Let's end this test. You can see we dropped from 96 down to 94. The electronic load is now connected to the accessory socket. We're going to be using 10 amps. Let's get that test going. And you may see a bigger voltage drop because of the wiring over here for the socket. It is a little thin, thinner than I'd like. We're going to let this run about 15 minutes. We have about 5 more minutes to go. Everything is just fine. We're just under 119. So an 8 watt drop across here, making the voltage lower than what it is on this side. But just to show you the voltage is still high, we're going to take a look over here at one of these ports. And here you can see the voltage for these ports. 1284. Okay, let's let this finish just to make sure it has no problem handling 10 amps. And this test is now complete. Not a problem at all using a 10 amp load. Let me turn it off. And you can see we dropped way down to 89%. Okay, the next thing I'd like to do, we know that this section is working well. Now let's take a look at this section right over here. Let's take this Apple iPad, plug it in right over here. And let's see if it starts to charge up. Here we go. Alright, we seem to have leveled off around 26 watts for the iPad, and this is way down around 5% charge. Let me let this sit for about 15 minutes. We'll come back, and then I'll remove this and we'll place a higher current load on the USB Type-C, and also do the same for the Type-A ports. Around 20 minutes has passed using the iPad, and it's always been right around 27 watts. Now I'd like to test something with a little bit more power, this MacBook. Should go up around 60. There we go. Make sure screen stays on. After about 20 minutes, I did not observe any problems at all. Now I'm going to be testing the upper two USB Type A ports, maximum 2.4 amps each. So I'm going to put a load tester on one, right here, set it for 2.4 amps. And then I'm going to put my cell phone on the other. Plug this in. Right there, hopefully you can see 2.4. Voltage is 5. Let's turn it on. There's the wattage popping up. And over here, 11.2 from my angle. 4.8 volts. Good. Let's let this sit off to the side. Put my cell phone over here. And plug that one in. I'm now going to let this sit for about 15 minutes to make sure there's no problem with these two ports. And guys, as they say, no problema. This works just fine. Now let's test the lower two. These USB Type A 3.0 are rated up to 18 watts each, or 1.5 amps. So let's plug the phone in again. Okay, now let's put this back in, but I'm going to have to lower the current on this. Hopefully you can see that right there. It's set for 1.5. Let's turn it on. Almost 7 watts. Fan should come on in a minute. And the voltage is 4.6. Could be 4.63, 4.64, but let's see if this can hold for another 15 minutes. And after 20 minutes, no problem with the lower USB Type A ports. Now let's go on to testing the AC receptacle. For the AC receptacles, I want to check the output. 116, that's fine. Now let's take a look at the frequency. It says 60. And 60.16. Now let's check it on 50 Hertz. Going to switch over. 50. And we're still coming up at 60. That is not good. That means the 50 and 60 Hertz switching is not working properly. Let me verify it by using a different multimeter. Yep. This does not work switching between 50 and 60 Hertz. Luckily, I live in the United States where I do not have any need for 50 Hertz. But if you're looking to purchase this unit and you need a 50 Hertz output, it is not going to work. Right here you can see that the AC output has a pure sine wave waveform, and the voltage is 115.6, which is very close to what I measured with my digital multimeter. The next thing I'd like to do is test the output for the AC receptacle. We're going to start with a motor first. I want to see how well it handles the inrush. So let's plug this in. I'm going to be using this Makita jigsaw. And let's see how it reacts. No problem with that. Let's try something a little more powerful. This is a flex grinder. It does draw way more than 500 watts, but I'm able to turn it down right over here where it says number 3. So let's plug this in and give it a try. And we just went into overload, so that's good, it works. Let's do a reset. take this hairdryer, I'm going to put it on a low setting first, just on warm. That went to overload as soon as I pushed it to high. Keep in mind the hairdryer pulls around 1500 watts, even though it says 1875. I did check it. It pulls around 1550. So this could never handle it, but it's very good to know that this feature of overload protection does work. AC adapter ready to go. Plug it in. And you can see it's charging by the movement in the blue bars. Over here is the input wattage, 91. And it says it's going to take 1.3 hours at 91 watts to top off this battery. Just like the Max Oak and other power supplies, this can get quite hot. And according to the manual, it's normal if this gets hot. So I highly suggest you place this somewhere out of the way, like in a garage on a concrete floor, because it probably gets between, it's around 185. That's pretty hot. So you want to place that somewhere where there's not going to be a fire hazard on a concrete floor, and you should be good to go. Now I want to show you the light on the back. Let's go over here before I do the actual test with the plug. To turn the LED light on, you just push it once, and it gradually comes on to the low setting. And it's going to be hard to see, but I'm going to turn this light off right here. It's a very nice soft white light. And on low, it's more than enough if you're out camping in total darkness to light up the inside of your tent. But you could push it again, and here it is on medium and high. So let's see what the light output is. 1 inch away, right in front. 40,000 lux. 1 inch away from the middle of that light. I want to show you one thing. I'm going to put this light on just very quickly. It's 70 watts. Let's turn this on. Everything else is off except for the light. 70 watts. And if you go to charge at the same time, there's the 70 watts. Output. Input 91. So you're charging and using at the same time. After 1 hour and 11 minutes, the portable power station has shut down. The portable power station had no problem at all, supplying just over 500 watts continuously. Based on this test, the battery capacity is 600 watt hours, which is pretty good. It's very close to the 614 that the manufacturer specified. With everything removed from the power station, I'm now going to charge this back up to around 85% after I wait about an hour for this to cool down. Once it's up to 85%, I'm going to take off one of these covers, or maybe both, so you can take a look at the inside. Once that's done, we're going to take this outside, connect it up to a 100 watt solar panel to see how well it charges. One thing I remembered when I plugged this in was to take a look at the voltage of the accessory socket. I told you earlier I wanted to see if it was regulated when it was drained down, and you can see it's 13.2. It's actually slightly higher. So there is some voltage regulation for this accessory socket. With the unit charged up to 85%, I popped out these rubber plugs, there's one in each corner, and removed each one of the screws. And I'm going to undo each one of these connectors. There's your battery pack. As you see, the end of this unit separated easily. Just disconnect all these connectors. Another one here. Then you have your flat cables along the top. Here's the fan. And over here is a light diffuser for all these LEDs. Yep. Let's take this off right here. This should allow the whole thing to slide out of the extruded aluminum housing from this end to that end. And then we can take a close look at it, and then I'll put it back together and take it on outside. Alright, so it's moving on the top, so it's secured probably from underneath. Let me flip it on its side and take a look at the rubber feet. There's probably screws under those. Sure enough, there are 4 more screws. And over here you can see it says capacity 614 watt hour, 12.8, 48 amp hour. And here's the input from the AC charger, which is 19 volts, 4 3/4 amps. Lithium iron phosphate, and it's an MPPT charge controller. Okay, with the screws removed from the bottom, this should now slide out. And there we go. Here you see all the guts from inside that unit. Over here are the MOSFETs or FETs. There's your negative and positive from the battery bank. And the battery bank right here looks like 32 650s for lithium iron phosphate cells. So 32 millimeters in diameter and 65 millimeters long. So if we go back to this side right over here, I can feel the cylindrical cell. There's one there, one there, one here, there. So there's 4 of them lined up. And over here we have 1, 2, 3, 4, 5, 6, 7, 8. So 32 of those 32 650 cells, which means you have 4 in series, or 4S, and 8 in parallel, or 8P. And that's about all that I'm going to be taking this apart. You had a very good look at the internals. And I have to say, this unit did perform extremely well. The only problem I really found with it is the 50-60 Hertz selection switch. It does not switch between 50 and 60 Hertz. For me, living in North America, it's 60 Hertz. I have no problem with it, but you're going to want to make sure you do not purchase this if you're looking for a 50 Hertz output. Okay, let's put it back together and take it outside to the solar panel. Right here, I took the portable power station and connected it up to one side of the 200 watt folding solar panel that I showed you how to make in a previous video. Right here, you can see where it connects to the back of the solar panel, runs down to the MC4 connector, which connects to the portable power station. You can see right here with the sunlight intensity at 78,000 lux, the unit is charging just fine between 88 watts and 93. And that's all, guys. If you enjoyed this video, then be sure to share the video link and my channel with others, because a lot of time goes into making videos like this. Thanks for watching.